Hey everyone, it's Jim
and Charles
from Mellow Amps, and in this first episode we're going to do the introduction to the new OTL kit headphone power amp. And it's a happy day because we spent a lot of time developing this kit, and let's just get started. So first of all, what are the tubes that it uses?
Okay, so we're using the 6AS7 or the industrial version 6080 or the Soviet version 6N13S power tubes.
Which is actually what's mounted right now.
Beautiful Svetlanas, and these were never meant for audio to begin with. They were meant for regulated power supplies, but because they have high current and low output impedance, they're extremely well suited for an OTL amp. And an OTL amp is just an amplifier that doesn't have an output transformer. We're coupling with a capacitor, and that really lends a unique and interesting sound.
And we'll actually, when we're done here in the music room, we'll head over to my lab bench where we will film most of the build series, and we'll actually show you those big coupling capacitors. And in fact, it's worth mentioning that the build series shows you how to do everything. The entire build, step by step. Now, we don't show you how to put every single resistor in. We'll show you how to put one resistor or two resistors in, and then, you know, set you loose to finish it up yourself. So, okay, so that's the tubes. What about the inputs, the outputs? How does that all work? Well,
It's not that complicated.
There's two RCA jacks on the input. There's a high quality 1/4 inch TRS jack or a stereo jack to plug your cans into.
And we have a power input and a DC input for the heaters on the back.
Yeah, and we'll look a little bit more at those details. But you might say to yourself, what in the heck are those large capacitors poking through the cover? Well, those are filter capacitors or reservoir capacitors, and they are huge. They're 1,000 microfarad, 250 volt Nishikans, and there's 6 of them. So there's actually, because this is a quasi dual mono design, there's 2 sides to the filter stage. So there's a left channel and a right channel. And we'll show you a little bit more of that as we go. Before I forget, there's a build manual online. It's a free PDF download, and it's got probably 99.9% of your questions will be in here, and maybe a lot of things you never even thought of. We put a lot of time into the build manuals. We even include a complete schematic. So this is the power supply schematic. There's a power stage schematic, and these aren't just sort of representational schematics. They're meant to help you during the build. So don't worry, if you don't know how to read a schematic yet, as we do the build, we'll talk a little bit about how the circuit works, and we'll be talking about what the actual schematic portion of the circuit is that we're building. So by the time you're done building, you'll have a much better idea as to what you're looking at in a schematic, and that'll help you with, you know, moving forward. The other thing that's really important is we have full set of specifications. And yeah, so what kind of headphones can we use in this OTL amp? Because that's one of the big issues with an OTL.
A typical OTL, yeah. They're usually limited to high impedance headphones, somewhere in the 300 to 600 ohm range, which limits your options quite a bit whenever you're trying to get headphones for an OTL amp. So our first thing that we were thinking about when we started designing this was that we wanted it to go lower. At least to 150 ohms, which is a much more common standard, and we were able to do that just fine. But then we kept going, and we were able to get down to 80 ohms, which is another common standard, and that's going to cover the majority of high-end headphones that are out there.
In fact, the output impedance is actually 70 ohms. So technically you could run a 70 ohm pair of cans.
If they exist.
If they exist. The lowest we could find to do critical listening tests were these Bear Dynamics.
These are the DT770 Pros.
They're closed back headphones, and for the money they sound amazing. Can you do better? Yeah, of course. They're really budget headphones, but they're great when I'm doing recording work. Closed back headphones of this quality are just perfect for that kind of usage. And at 80 ohms, they sound amazing. Now, if you want to do something closer to the optimal impedance matching, you want to do something 150 to 600 ohms.
So that's something like these Sennheiser HD 660Ss. This is the first version. There is a second one out there that's very similar.
And I think they actually built them, at least when we bought these, in two different impedances.
Yeah, they're in 150 and 300 ohms, and these are the 150s.
Yeah, now they're open back. This will get you to an audiophile grade sound.
And they've been around for a long time. They're very well regarded, and for good reason. They're great sounding headphones.
Yeah, I mean, I can remember the first pair of headphones I bought in the 1970s were a pair of Sennheisers, and they were great back then. And headphone technology has improved immensely in the last 20 years. So
now, one thing that we also thought we would need at the very beginning of development here was a whole lot of driving voltage. We thought we were going to need a very high gain preamp to drive this.
Well, actually, we sort of do, because if you want to reach the maximum output power of the amp, you need 24.2 volts RMS coming in.
And that gets you just over half of a watt output. There's only one problem with that. Half of a watt output into these headphones will blow your head off.
Yeah, and it might even turn that gel-like stuff between your ears to mush, if it isn't already. So that's not a good idea. So what do you really need voltage-wise coming in to drive to, let's say, a normal listening volume? Well, let's take a look at the manual.
These are probably the least efficient headphones that we have.
They're 96 dB. And you need 0.16 volts RMS to drive them to a normal listening level. What about the more efficient Sennheisers?
Well, these are all the way up at 104 dB.
And you only need 0.065 volts RMS. So put that into context. The typical standard for line voltage in a home system is 1 volt to 2 volts RMS. So
most devices with a standard output on it will be able to drive this to full volume with no issues at all.
Will the system sound better with a high gain, low noise preamp? Probably, but not necessarily. A lot of DACs have built-in gain stages, and if it was well designed, the gain stage may well sound very good. But you can go totally budget. You can go with something like a digital music player, a DMP, an old FiO. This is an X5. It's my first DMP, and I've owned many of these over the years. And this first generation, well, it's the last. I shouldn't say it's the first. It's the last of the old school type. So there's no fancy operating system. It's like going back to the early computer age. But this thing sounds stunning, and you can buy these used for next to nothing. But if you've got the bucks, or you already own an Astel and Kern Con Cube, these things are amazing. And you might say, well, you're plugged into the XLR out, and we are, but this is a custom-made cable, so I'm only capturing one leg of the XLR for each channel. So, and those cables are commonly available. Or you could do something like our Proto DAC, which is another really great sounding DAC that you can homebrew.
Yeah, there's all sorts of options. This really opened it right up. Originally, we were thinking you were going to need a high gain preamp no matter what, but that's not the case anymore. You can plop this on your desk and plug just about anything into it and get out some great sound.
Yeah, and talking about plugging in, when you do a build, you've got to break in the tube sockets because they're brand new and they've never been broken in or stretched to fit a proper pin, and that can damage a tube, and you don't want to damage a high quality vintage tube. So if you don't have a box of scrap octal tubes lying around,
like we do,
just drop us a note when you make your order and say, could you include a junk tube so that I can break in my sockets. We've got Charles filters out thousands every year, and most of them we just chuck, but we keep a box for this purpose. The other thing that is a pro tip is that Charles designed these build stands, and we're actually on the second version. This is the S2, and it's designed to really make it easy to build. They're not expensive. And they actually have two heights. It's hard to see, but there's a high height and a short height. And what that short height allows us to do is to get these capacitors on the board, on your bench, and held in place for easy soldering.
It makes a huge difference.
Charles invented these build stands initially because we do production runs, because we actually sell completed amps to customers who just don't have time or the interest in learning how to put together their own gear. And these work so well in bulk manufacturing that we actually thought, well,
why don't we sell them?
why don't we use them? So
Yeah.
I remember the first time I built a board with the stands, I said, where have these been all my life?
Instead of propping things up with wooden blocks or a book or something.
Okay, so that's enough yapping in the music room. Let's get into the lab and open this thing up and have a look inside.
Yeah, let's go.
Okay, so this is the bottom. There's actually going to be a label that'll sit here that'll
depend on what your region is. So this one's just blank.
yeah, but it'll show the fuse values that you use, etc., like that. So here we are inside. Now, one of the things that we haven't talked about yet is, what does this amp sound like? Well, it sounds truly amazing, but the secrets to great sound are not complicated. Choose a very good tube. 6A7 with its high current capabilities is a fabulous power tube. Go with very short signal paths. Choose quality components and do a decent job designing the filter stage and the amplification stage. And I would say we did much better than decent. We put a lot of work into it. So in the back you've got your cooling fan, which runs at a very low speed, and these are quiet fans to start with. So you will hear it when the amp is on, but it's so low that it would be, when you're listening to music, you wouldn't even know it's there. There's your IEC. The wiring in the back is a little bit tight, but it's doable. We needed to keep room so that we could lay out everything that's hot with some space. So here's your 3 filter stages, 3 different 10-watt wire-wound resistors, and you can see how the quasi-dual mono design works. Basically, it's 2 mono amps inside one chassis sharing a power supply.
Well, part of a power supply.
Yeah. So as we move forward from the filtering stage, we get into the actual amplification stage, and there's not a lot to it. Now, some of the components are on the other side of the board, of course, so we can't see them right now. So smaller stuff and things that don't get too hot go on the other side. Things like these 10-watt resistors and these 50-watt resistors, these are the cathode resistors. These are what set the operating point of the amp, and they get hot. So you can see they're mounted to fairly large aluminum heat sinks. And if you look at the way Charles designed the bottom plate, it's really quite interesting. So he did some airflow modeling and figured that we would put larger holes here and smaller holes here, and we would be able to draw out...
draw cool air in across the resistors and out through the back.
And it's worked absolutely brilliantly. I did initial modeling tests, initial actual bench testing, and I spent hours checking temperatures, and it keeps everything nice and cool, which will make for a much longer lived amplifier. Over here we have our huge coupling capacitors, and there's your output jack, and that's all there is to it, folks. And it's going to be a fairly easy build, but there's going to be parts, aspects of the build in which you'll hear us say, "Caution, everyone, pay attention," and we'll show you the
right order to do things in, because it's really important in a couple of spots.
Yeah, and we'll also warn you ahead of time about things that can get you into trouble if you like racing ahead. So
as usual with these videos, watch through the video first and then do your build afterwards and follow along with us, because it'll help save a lot of headaches and trouble.
Yeah. Okay, well, what's next, Charles?
Well, I think it's time to start getting organized for the build. We'll see you in the next episode.